In this video, we'll take a look at how to approach a simple design project using this rocket as an example. The main method for making is 3D printing. It was inspired by a design project I did with students where we built this model from a kit by Estes rockets. It's a simple design based on the A-size rocket engines. It flies well and forms a good basis for exploring more ideas. And that's a really important point. It's okay to explore ideas that others have made before you, and it's a good idea to always acknowledge where those ideas came from. A quick preview of the finished product shows you that it prints quite well. There are a couple of areas where it's a bit unfinished, and you can see that the fins are quite thick. Actually, overall it's kind of a heavy design. But that then led to other designs which also turned out, well, quite heavy. Some ridiculously heavy, such that they flew but quickly crashed and burned, like these ones. But there are people out there 3D printing rockets, like this design that I found on Thingiverse. Again, you can see that the design looks quite heavy, thick tail fins. In this video, we'll focus on how this one was designed, made, tested, and evaluated. As with all design projects, it's essential to record your ideas and sketch everything you think of. Get yourself a sketchbook and a bunch of pencils. With this first design, it happened on one page. Don't be shy about cramming your page full of ideas. Makes them easy to see in a glance. These next pages are the heavier designs. What I didn't realize at the time was that my ideas were getting worse, not better. But that's design. This page here opens up a new approach that I discovered as a result of making a few mistakes, and I'll cover that in a separate video. It's an important part of resolving a design. So here we are in Fusion 360, which is the app I used to design it. I won't go into the details about the 3D model, but I used Fusion to produce the STL files for 3D printing. And you can see it prints quite well, largely because the walls are quite thick and not so prone to breaking. But how does it fly? Here we are for Launch 1. A clean takeoff and a really nice flight path. I was quite surprised. But things started to go pear-shaped when the recovery charge fired. Right about now. The parachute didn't deploy, and I was left with a falling dart. A good reason to make sure you're doing this safely, and perhaps not making the tip of the rocket quite so pointy. A few adjustments to the nose cone, and we're off for Launch 2. Again, a great takeoff, and an even straighter flight path. It was looking good. Then, uh-oh. What's this bit up here? It's the chute, and it's not attached to the rocket. So, crashed and burnt again. But hey, 2 good flights at least. So where to now? Well, that led to the design of lighter weight models with better tolerances in the nose cone. This one is actually ready to fly with the recovery system already installed. It'll be interesting to see how that one flies, especially since the fins are much smaller and thinner. This one is more similar to the original Estes design at the base, but I got a bit carried away with this version and ended up designing something that looks more like a cruise missile. What I learned from this project is that weight really matters, even though it hardly weighs much at all. And the challenge continues. How lightweight and effective can these designs be? We'll take a look at how these ones fly in another video. Thanks for watching, and see you next time.